One of the things that are essentially brought up as the interest to get into space. And many people ask, how do I get into space? It's now becoming a buzzword with Elon Musk spreading all sorts of waves all around and making space cool. But initially, space was not very cool. As in, every time there used to be a failure, people used to attribute that failure and the cost of that failure with the amount of food that could be fed to the poor people. And that is a very myopic way or very short-sighted way to see space. One of the reasons being that the outcome of space is essentially to make things more and more efficient because of the environments that we have to survive. And henceforth, one of the interesting outcomes of space is the camera. The digital camera that you see now is because the space wanted something very, very efficient. And GPS is also one of the outcomes of space, which now everyone takes it for granted, considering that you get Zomato and Swiggy and all of that right onto your doorstep. So people have now started seeing the long-term possibilities of space being able to touch each and everyone's life as and when there is growth in space. So henceforth, people now start to see the coolness of space, apart from the fact that there is this launch and other cool aspects of it. Now, as we get into it, I'd like to get into the facets of it. So I am a spacecraft designer, and I work with team members working on a spacecraft to the moon. And I'd like to speak a little bit about that, and henceforth, perhaps try to get your appreciation as to what it takes to develop and design a spacecraft. And then the next part of it, what I'd like to get to is what are the skills required for us to get into this. And henceforth, the final one would be, I'd like to get your attention to how patient should one be in the space industry. And that is something that I want to bring most of your focus to. So can we go to the first slide, please? The next slide. All right. So we have a very short slides here. And here we have two spacecrafts. The one which is at the rear is the first generation spacecraft that won us $1 million. And this was the lightest spacecraft amongst the full world, as in we were participating in a competition called the Google Lunar X Prize, wherein teams from all over the world participated in it. And we were given the opportunity to create a configuration that would go to the moon, deliver a payload, which is a rover, and drive 500 meters. This was essentially a competition that was created so as to incentivize private players to come into the space industry. Because as you know, space is a very, very costly endeavor. And for it to start becoming viable, there needs to be some sort of a hand-holding for the initial stages, because failure can be fatal in the space industry. Because the cost of each launch is close to around 400, 500 crores, excluding the engineers and the hardware and other aspects of it. So if you fail in one mission, essentially that would be the death of the institution, because you do not have a government backing it up. So henceforth, if you start, if big organizations like X Prize, which was backed by Google, could do it. So that was the whole aspect of it. Sorry, I had a small. Big companies like Google had had backed the X Prize Foundation with an intent that they could incentivize these small milestones, like building the spacecraft, creating other technological milestones and other aspects of it. So how did we participate, and what were the challenges that we did? As an engineer right out of college, we had to solve one of the major issues. The first major issue being of talent. and capabilities. And that was essentially the biggest problem that we had. And one of the major things that we had to face is that no matter what and how capable you come out of college, it is impossible for you to know how to design and manufacture a spacecraft. And that is essentially what we had to go through as a learning curve. So this learning curve was had to be done in a very, very short period of time. And can we get to the next slide, please? Yeah. So what kind of people worked with me? So I am basically an aeronautical and an aerospace engineer. So that's my primary background. I work on designing configurations, making sure that they work well in unison. And there is mechanical engineers who work for me, who get into the details of the structural design, considering that we have a viable configuration. There are electrical engineers that make sure that there are wire harnessing and there are solar panels essentially and batteries, all of them, how do they work? And electrical engineers like Deepna, she is also one of the engineers. She works on finding the logic for how these engines, the thrusters, should be firing. And under the bracket of mechanical engineering is thermal engineering, which starts off in the bachelor level. You branch out to become a thermal engineer after you become a mechanical engineer, and they work on the propulsion part of it, how the engine fires, and etc. and etc. The computer science department, it works on making sure all these mathematical logics get hard coded into the computer. So obviously there has to be a computer on the spacecraft. So electronics and instrumentation, all of them have to work in unison with the sensors and all those coming in unison. So there is this IMU, there are star sensors, there are sun sensors, and many such sensors that play a role in determining the overall part of it. Pure maths and pure physics, these two are actually very, very malleable, meaning if you have the background of pure maths and pure physics, you could fit into any one of them, apart from perhaps computer science, which requires a certain amount of prerequisite skills, or even, may I say, thermal engineering, which requires some prerequisite skills to understand. But if you have physics background for thermal engineering, that should be fine. But computer science requires certain jargon, which is essential. But besides computer science, every other skill is a subset of maths and physics. So if you are very, very passionate about maths and physics, you should be able to perhaps jump into any one of those fields. And one of the major fields of the offshoots of the maths side of it is the orbits. Which orbit is most efficient to reach the moon? So those mathematics are done by people with pure mathematics background. So these are the places where we function. Can we please go back to the previous slide? Yeah. In this, you see that the closest one is the spacecraft that I was participating in qualifying it, and this particular spacecraft was even recognized by NASA in their website. So we were really, really close to sending this spacecraft to the moon. So perhaps in the future we would be sending this spacecraft to the moon, but that's just, our hopes are high on that. If you can see closer to the spacecraft, there's a small rover there with 4 wheels there. That is the Japanese rover. The Japanese did not have their own spacecraft, so they had to integrate their rover along with us. Our rover was on the other side, which is just opposite to it, on the other side. The other aspects of the spacecraft, let me discuss before we get into the other details of the profession, is that the spacecraft goes through a lot of tough environments. And henceforth, the spacecraft is one of the most efficient entities because it has to be. Each gram that goes into space weighs more than a gram of gold. So I think it's close to 10 times the cost of gold. So every gram has to be accounted for. And we use aluminum honeycomb structures, 0.2 mm thick, and foils as thin as the same size as that of the aluminum wrappers that wrap your chapatis. No, we use those same foils in a honeycomb configuration, and we put 0.2 mm phase sheet top and bottom, and this full spacecraft is made of these two entities only, put in the right directions. So a spacecraft is made of aluminum honeycomb sandwich, carbon fiber, one of the cutting edge technologies to make sure that it is lightest as possible. Majorly, the spacecraft is aluminum. We couldn't go to carbon fiber because we need grounding. Every electronic system requires some sort of a grounding, and henceforth we had to settle with aluminum for its electrical capability. Carbon fiber is not conductive in nature in its current form. Carbon in general is conductive, but carbon fiber in its usable form is a combination of a resin and graphite in a specific structure, and that's what makes carbon fiber composite. So this carbon fiber composite in this configuration is not conductive, and henceforth we had to choose aluminum. And we have 4 landing gears for this spacecraft. These 4 landing gears had to withstand the final fall of the spacecraft on Moon. Why do we have to fall from Moon? Because if we fire our thrusters really, really close to the Moon, it kicks up dust, and that dust would fall onto our solar panels, which eventually would kill the mission. So henceforth, we had to cut our spacecraft something around 2 or 3 meters above the ground, and the spacecraft would fall. Many of you, if you have the time, could go to YouTube and type Team Indus drop test, and you could literally see a functional model, just the landing gear. We are dropping and testing its capabilities and trying to see whether it will withstand. You will notice that the height at which it is being dropped is about only just about 1 meter, but we are going to drop it on Moon something around 6 meters. Can you hear me now? All right. I hope the audio is fine.
Fine. I think it's the local. It's absolutely fine.
Okay.
Check with a few others.
All right. So the spacecraft will be dropped at something around 6 meters high on Moon, but on Earth we are going to do it 1/6 because the gravity on Moon is 1/6. So in order to replicate the same environment, we are going to drop it 1/6 the height, and that would ensure the same forces that the landing gears would face on Moon will be subjected to it. So this is the overall aspects of the spacecraft from a structural standpoint. We have solar panels also on our spacecraft that are highly efficient, and their only job is to ensure that they face the sun. But these are fixed panels. Because they are fixed panels, the mission will be a failure if our GNC, which is the guidance, navigation, and control, does not orient the spacecraft correctly when it lands. So that is also a mission critical design in the overall process. To make sure that the solar panels, the interest is that all this effort is just for 14 days, half a lunar day. Which a day of a lunar day is basically 28 days, and 14 days happen to be in the during the lighted condition, and 14 days happen to be in the dark condition. And we are not able to survive the dark condition because the temperatures go too low. And what is the concern? The structure can survive, but there are other aspects which cannot survive, like the battery and other aspects, which changes its chemical composition at very, very low temperatures. So all this effort to go to Moon is just for 14 days, and it's very, very expensive. And the offshoot of this, if one could see beyond this lunar mission, which is just of 14 days, is excellent rover capabilities, which could perhaps be used in Earth situations, Earth-like applications, which just has to be modified to meet its current requirements. So these offsets will be after we have a successful mission, and that is what the space tends to do. And now it's all a fad that we want highly efficient solar panels and all. This solar panel was a primary requirement for the space industry. Now we have an efficiency of the solar panel something around 18%, I believe, for commercial, but the space uses something around close to 29% or upwards of that number. So we use a very, very high efficient solar panels, and that trickles down to the commercial industry. Because of our requirements for it to be that stringent, we slowly start making it more and more viable, more and more viable. And hopefully you will start seeing solar panels that are more and more efficient coming back to us. So it is a very long process for it to reach the common man, but effectively it does reach. Where will it go? The whole point of us is to learn something new in space and give it back to the people. And this whole, may I say, this strenuous act of going to space is basically testing the human capabilities and making sure that the entrepreneurs are able to later monetize it. And that is the overall aspect of the space. One very interesting thing that I'd like to tell you is that if many people say, what is the use of relativity, special relativity and all? Just for your information, if we did not take into account special relativity or Einstein's theory of relativity, which mota sa, what it says is that the change in gravity results in change in time frame also, which means that the satellites that are orbiting us have a different time frame. And because the radio waves travels in the speed of light, the smallest time correction, because it is going at a different time, and there's a small difference in time, as in 1 second of time on the satellite's orbit and 1 second on Earth is not the same. They are different. And that small difference makes a huge difference to the extent of 40 to 50 meters. If we do not make the Einstein's theory of relativity correction on the satellite and in our spacecrafts, we will not be in sync with regarding to how it is really working in real time. So we need to have that equation. So one very, very important use case that everyone experiences it without the understanding of relativity, I don't think the Zomato and Swiggy would all have made sense. So one thing one must appreciate Einstein's theory of relativity is every time you click on deliver me food, there is a whole lot of rocket science that has gone into making sure that food comes to your plate and to your address. Next slide, please. Getting back to the profession. Yes. So one very essential part is that many people think this slide is specifically to tell that the skills required to get into space is not only one. Anyone can enter into space. Anyone, literally, even doctors can enter into space. But even though the current requirements for doctor in space is very, very low, as because astronauts are very, very low. There are max to max about 200, 300 astronauts. So there are about 200, maybe some 150, 200 doctors, not specifically for them, but to develop medicines for space, because microgravity conditions have got very large implications on people. One of the reasons being that isolation is one of the very, very big issues, because when you're traveling from here to, let's say, Mars, it takes 6 months to go from here to Mars. So how would you keep yourself engaged? There are people who are trying to make drugs to make sure that you don't go insane when you're going to research. So even doctors could literally enter into our field. So there are no restrictions to any particular field to enter into our space, but there must be an understanding of maths, physics is essential. High probability that if you do not have a liking for physics and maths, you will not have a successful career in space. That being said, can we please go to the next slide? Yes. So one very essential thing that I want to bring to your notice is that I just wanted to have a comparison between information technology being a career and space being a career. The space, I've just put in a pictorial way, has a very, very low frequency of projects. I mean, the project cycle is very, very it's got like once in 5 years or once in 4 years only a project gets initiated and it gets run upon. Information technology is very, very fast. The number of projects are number one high, and they don't last very, very long. The projects on an average last not more than 6 to 1 year. That's the overall average thing. So henceforth, it's like understanding what is the time frame when it takes when the industry starts to intake people, because only once in 4 or 5 years will a specific company consider hiring more people. And so that is why you must have a lot of patience when you are in space, and perhaps the bandwidth to sustain the tough times and not question your competency. There have been times when I was not employed for over 6 months, and I did not know that this space industry is going to be this tough. And it took me close to 6 months to get into this job. And even after that, there were lull periods wherein we were trying to recalibrate. And because of the fact that space requires a huge amount of momentum for it to reach its fruition. So these are essential parts which I want to bring to your notice, is that when you are coming into space, make sure that you do not have too many financial obligations, because you might possibly be we might possibly not get a job very, very soon, as soon as the information technology career. So that is just one conditions apply, if I may say, to ours. But it will soon keep on improving, and the frequency will keep on reducing as we have more and more space industry and we start improving and standardizing the designs. There will be an improvement. But having said that, initially there will be initially there is a huge lag. Having said that, because that there is a 4 year to 5 year cycle time for each projects, the expertise required in this field is expertise expectations is very, very high, meaning that you must be exceptional in your field of whatever your choice is, be it a specific area like may I say thermal design or structural design or GNC or communication. You must be very, very good with it, because we cannot afford to hire people who cannot deliver the best, because one mission failure was it leads to a loss of close to 800-900 crores, which means that each one of us cannot be the weak link in the overall system. So that is also one more aspect to it, is that while you are in space, you must make sure that you're constantly upgrading yourself. Keep on improving, try to see what are the trends. Can you apply different logics? Can you get inspired from different subsystems or different fields? We have taken a lot of inspiration from different fields, even automotive fields in that regard. So everything is up for taking inspiration from. And one essential part of space I'd like to conclude about is that perception and different perceptions matter, because essentially in the space industry, we believe that everyone is smart enough, because given a question, everyone knows how to answer it. Everyone's smart enough to answer a question, but nobody is smart enough. Not nobody, my apologies. Very few are smart enough to understand which question to answer to, or formulating the question itself. What next to do? It takes a lot of, may I say, intelligence. I would call that as true intelligence, to formulate the right questions, because answering a question is very, very easy. Only formulating the question is going to be tough. And that is what is in space. As in, we have to formulate the right kind of questions, and the most efficient questions get the most efficient answers, and henceforth that only results in most efficient solutions. Just to give you a small example, perhaps I may have confused a little bit in the regard that, let us just say that you want to build all right, let's just say that you want to build a solar panel, a solar tracking system. The most important question that you will have to answer is, what is the power required? whether do you need tracking or not, these are complicated questions. To answer it simply, you will have to take a weighted average of all the possibilities and make sure that it answers it in the most simplest way. The most simplest answer will be as an outcome of the most clearest question. Uh, Owing to the time constraints, I'm not able to take a very a better example, but I'm sure that you would have come across in your day-to-day lives that a better question always leads to a better answer. I'd like to yield my time and perhaps give way for some questions. That would be fine. All right, so we have some questions. How to get a PhD in physics and what are its advantages? All right, very interesting. Sorry.
No, it's absolutely fine. My only request would be, kids have also voted for questions.
Sure.
So if you allow, we would use the ones with the maximum interest so that, we are able to cover more kids in one shot. So this one is from Jessica. So what are the skills required to become an aerospace engineer? Guys, hold on. Aerospace engineer, and what are the steps of becoming an aerospace engineer?
All right.
Skills required and steps.
The required steps to become an aerospace engineer. All right. I have a slightly unconventional way of attacking this problem. If you want to become an aerospace engineer, I'd like to take the same point that I ended with. You must be able to formulate the right questions very, very efficiently. Take up a problem statement and let us see how efficiently can you solve that problem. Any problem statement. So let it be like if you want to make a small rover, a robot, or whatever it is. But a practical problem, you must take a practical problem and show that you can answer it as simple as possible. People say that rocket science is very complicated, but I would say that rocket science is the simplest answer to the most complicated problem. And that is my answer to you. You can choose, Jessica, you could choose any path, any project you would like to choose in the plethora of professions like mechanical, electrical, or whatever it is, but take a practical problem. Take a practical problem, create a problem statement, and make sure that you have the best answer for it.
Next one is, if we have to take science field for going to space, do I have a scope? Let me rephrase it. Do I have a scope if I'm a commerce student?
Okay, from a commerce group, if you have to get into space, is that the question? All right.
Yes.
So as a commerce person, if you would have to get into a space, perhaps you could get into the financial aspects of space, as in look at which problem statement is very, very crucial in the terrestrial domain. Have a financial risk analysis of which problem could be best solved. Like for instance, the GPS. The GPS is actually an outcome of how best can it be monetized. So Zomato, Swiggy are all financial people. Actually, Zomato is actually the CEO of Zomato is actually out from one of the consulting. I think it's BCG Consulting or something like that. So he is essentially commerce. So the CEO of Zomato, who has created an offshoot of space. So you will have to create applications for space, and absolutely everyone can participate in it. But yeah, try to see what is making monetary sense to people.
If you're okay, Ananth, I would now like to look at one student asking this, asking a question directly to you. Is that okay?
Sure. Absolutely.
Go ahead, Ria. Ask your question.
Yes, sir. My question was, what are the careers, career option for one who is interested in physics and maths?
All right. Actually, the career options for people who are interested in physics and maths are close to infinite. You could literally fit yourself anywhere. But having said that, because the career in physics and maths are ever evolving in the regard that you need to specialize very, very deeply in physics and maths for it to start becoming useful to people. You cannot immediately just like you cannot compare yourself with an IT professional who learned to code in 6 months and is getting a job as compared to a maths professional or a physics professional who perhaps even has to consider doing a PhD. But it is certain that people who do a PhD in maths and physics have viabilities everywhere. And to my surprise, just about a couple of years before, I learned that a person with a PhD in physics is working in Wall Street. So that is very, very cool. So I think that explains that people who have a degree in physics can literally have possibilities to work anywhere. Uh, I didn't know that you could employ physics PhDs in Wall Street.
It's basically their their analytical ability, right? Uh, and that's the
Also,
reason why.
actually, it is a very different thing. So the Heisenberg's uncertainty principle is how the people's mind also apparently works. So they apply the Heisenberg's uncertainty principle and those quantum mathematics on predicting the unpredictable nature of people and making money for Wall Street. So I hope, Ria, I have answered your question. The possibilities are infinite. You just have to make sure that you're passionate about physics and maths. You have to be very passionate about because you'll have to sustain a very, very long time without getting a job because you'll have to get to that level of depth for you to start becoming useful to the society, if I may say that. Perhaps it's too harsh, but yeah.
With your permission, Ananth, I want to come back on the previous question. Someone from commerce, they were asking, right? Guys, while you cannot get into those science or technical fields, we had the opportunity of having Deepika, who's a 5-year law graduate and currently working in with Airbus in their headquarters. So opportunities are there. It's not restricted. The next one, it had to come. What should I do to if I have to become an astronaut? How do I become an astronaut, and what are the exams that I need to take?
All
this
right.
is almost constant in every space.
So fortunately, I have one of my mentors who is NC Bhatt, who was supposed to become an astronaut, and unfortunately, the astronaut project got cancelled because of the Kalpana Chawla event. For those who didn't know, that there was a space shuttle that went to the low Earth orbit, and while it was re-entering, it disintegrated. So that was a very sad disaster that could not let the other astronauts and the preceding missions to continue that. Because of its safety nature, they had to pull it back. I can tell you what were his capabilities. So as an astronaut, you could have perhaps 2 or 3 capabilities. In general, it will keep evolving. One of the most important aspect of an astronaut is simply the ability to withstand all these tough nature of space. It's going to be very violent when during the launch. So you have to be very tough. So mostly fighter pilots are taken and they are able to execute decisions. So they are able to execute orders, sorry. And you'll be given orders, conduct some sort of a spacewalk or something like that. You must be in mental condition to do it. So mostly people from Air Force or Air Force pilots get into that. There's another. There are payload specialists. People who know exactly what to do. As in, you cannot have a fighter pilot go and repair a Hubble telescope. So there was an issue with the Hubble telescope, which costed nearly $1 billion to repair the Hubble telescope. there was an issue with it, and they had to send a payload expert along with it. So there are payload experts that go along with as an astronaut. So they will obviously have to undergo all these challenging situations, but that is one essential. Scientists also get to be astronauts in the regard that there could be unexpected results that could come because of certain experiments in space. How could one re-strategize and recalibrate the experiment? How could that be possible if you're not a scientist? So scientist could be a microbiologist, a physics scientist, mostly microbiologists, because now people are starting to see how they can survive in space. So for survival, they will have to perhaps grow potatoes. I'm sure you would have seen Martian movie, wherein they're growing potatoes using, you know what, as manure. These are possibilities, and for which we need to start understanding. And one very cool thing is that because of the fact that these microbiologists did experiments on the space, they have now found out a specific wavelength of light that you could use to power the plants. So technically, you could literally have a garden in your basement with these LED bulbs, and they're not very expensive. So they have a specific wavelength which the plants could absorb and do photosynthesis. So yes, space has created a possibility where you could literally have a garden in your basement. So you can take a look at it, what wavelength, what kind of tube lights, and all of that. So I hope it answers your question as to what kind of people can become astronauts.